Hello, I am Simon Parkin from Delft University of Technology, and in these videos I will be discussing the human aspects of security and privacy. Complex computer systems, such as those of organizations, or third-party services such as email providers and social media platforms, involve humans. These humans can be users in an organization, typically employees, but they could also be home users responsible for their own use of IT. We will refer from here on to those humans who use a service, the end user, as users. There can be specific, discernible groups of users who use a specific set of technologies or services. This can, for example, include system administrators or a company's finance team within an organization setting. For home users, this could be an individual using a social media platform or parents and families using media streaming services. There can also be groups of users who differ based on particular characteristics, such as older users. We can then begin to consider that different user groups have different goals or needs and different conditions under which they are using digital services. They also have differing incentives to follow a particular course of action based on what they are doing. In terms of competence in security, there can also be users who are experts in using security technologies and non-experts. The distinction is often coarse, where those who manage a technology or platform or who work professionally in security or IT are assumed to be experts and other people not. As an overview of the course structure, this first video introduces basic concepts and distinctions that we will build up through the course. The second video considers users in managed environments, such as a company. This is followed by looking at security for members of the public as home users. After looking at these broad contexts, we will look in further detail at how individual users make decisions about security. In the fifth video, we give specific consideration to personal privacy decisions. Toward the end of the course, we will look at the potential harms of attacks, but also of security controls themselves. This informs closing discussion of directed interventions in security and privacy, where care must be taken in how we make improvements for users while also providing increased protections. We can generally say that, unless someone is working in defending IT systems, that security is not the main activity they are interested in. We want users to be able to reach their goal. In an organization, for instance, that means doing their job, and to be able to do so securely. So a user has primary or productive tasks, and security is one of potentially many secondary tasks. A task can have mental and physical costs as the workload. Mental cost can include recalling a password and remembering a step to follow in using technology. For physical costs, in the case of a password, an example of a physical cost would then be the effort of entering a password. There can also be costs to switching between tasks, for instance when entering a one-time code from a phone into a computer as part of two-factor authentication, or remembering where in a primary task the user was before an operating system update restarted their device. Where primary and secondary tasks interact, this is not always in a serial fashion, but can also be in parallel. Users in busy workplace environments are manipulated by phishing emails not only because of the convincing content, but because workplace distractions and pressures may mean it is difficult to focus all effort on examining each email. Commonly in security, the costs of tasks are regarded in terms of time, for example, how long it takes to enter a password or one-time code. Users also lose productive time, such as work time, if they're using that time instead for security. There are also costs in terms of complexity and how many things a user has to know, remember to do, or to navigate between when performing a task. For instance, how many passwords we expect a user to manage can affect this. This is then where we have differences between those who have made a system and know it well, and non-experts who use the system or service for their own means. A user does not have to know how the internet works to use a website, but some security threats mean that a user may be asked to examine some technical information about a website to ensure they are secure, such as looking at a browser address bar. Another example would be when both home and work users are advised to avoid use of public Wi-Fi, as a reference to insufficiently secure Wi-Fi. Are we asking the user to check if there is a Wi-Fi password, or to check the network protocol, or vet the trustworthiness of the Wi-Fi provider? How straightforward is it for a non-expert to do these things? It is then important to consider the costs of tasks to users, because they are not necessarily visible to those managing the system, such as a Chief Information Security Officer or CISO in a company. There are then these hidden costs for the user. It is not as easy for users to act securely as an expert might think it is. It is also important to consider the knowledge and skill expectations on users for two reasons. Firstly, malicious parties may seek to exploit a lack of knowledge or a lack of skills to their benefit, and it is difficult for a user to begin to consider whether a convincing-looking phishing email claiming to be from, say, the tax authorities is not from the tax authorities unless they know how to inspect specific parts of the email, as an example. So system owners must also take care not to assume that user effort is free, which would in turn burden the user with more effort and security tasks when threats increase and evolve. Ideally, technologies will be deployed to manage the effort where they can do what is being asked of the user. However, this does not always happen effectively. When designing secure systems, we ideally want that system to provide security benefits to whatever primary tasks the user is engaged in, and not obstruct their legitimate goals. Secure systems should also balance the costs and suitability of user security measures with the effort required of the user to reach those legitimate goals. That is, we should secure systems for what users want to achieve and fit security to their context of use, because users are not in the system solely to contribute to the security of that system. If that were the case, we could turn off all the computers and not use them for anything. If a user is not behaving securely in accordance with the expectations of the system owner, it is not always then that what they were trying to do is inherently wrong. Systems and user support can be improved to make it easier for a person to reach their goals and do so securely. One place to look is how security matches the primary task. For instance, if when logging into online banking, gaining access takes longer than the primary task itself, such as checking a balance, it can put users off from using online banking as much. They then experience less of the benefits. It is not that there is a stark choice between having a secure system and having a usable, productive system either. For instance, two-factor authentication arguably achieved traction because it leveraged that most users in those environments already had mobile phones with them. The security leveraged the convenience already provided by the phone, whereas prior to this, two-factor authentication technologies required users to carry an additional device with them, such as a banking keypad or a USB authentication token. Another challenge has been in managing passwords. Users can potentially have lots of complex and unique passwords for various accounts. Each service is concerned with its own credentials and not those of other services. Historically, this problem has been left to users to manage themselves as an externality. Password managers, including in-browser password managers and standalone applications, emerged as a solution to the problems of password recall, and second to that, entry and creation. When viewing an overall system, it is then important to consider who the humans are within that system, because we want to protect them from threats, but also ensure that they can reach their productive goals unimpeded, without security imposing heavy costs and expectations. There is much still to be done to design secure systems that align with what users want to do with digital technology, and we will cover some key elements related to these ongoing challenges in this course.